This is the second video for section 6.6 and the final video for chapter 6. And this discusses Cramer's rule for solving three linear equations in a system. The process is going to be exactly the same as it was for a 2x2 system. In essence, our denominator is going to be the coefficients on x, y, and z, and whichever variable we are looking for, we will replace that column by the constants on the other side, in this case d. So you'll notice that for x we replace the first column, for y we replace the second column, and for z we replace the third column of coefficients with our constants on the other side of the equation. Keep in mind that for all of these systems of equations, we need to have them in this form where the x's, y's, and z's are all in their proper place and the constant is on the other side of the equation. So let's try a 3x3 system of equations. And again, sometimes it is helpful to just find the denominator first. So let's do that in this case. We have 3, 2, 5, 8, negative 3, 2, 7, negative 2, 4. Again, this is a 3x3 system of equations, so we're going to repeat those first two columns. So 3, 8, 7, 2, negative 3, negative 2. Now, if we go through, the diagonals going down are going to produce 3, negative 3 times 4, plus 2 times 2 times 7, plus 5 times 8 times negative 2. The diagonals going up are going to be negative. So we have 7 times negative 3 times 5 minus negative 2 times 2 times 3, and then minus a 4 times 8 times 2. In this case, when we simplify, we have negative 36, we have plus 28, minus 80, plus 105, a plus 12, and a minus 64. So when we add all of these together, we end up with negative 35. So it's not 0 in this case, and this is going to be the denominator for all of our variables. So if we come back over here, we know that x, what we're going to do is we're going to replace the first column with our negative 7, 10, 1. And we're going to leave the other two alone, so 2, negative 3, negative 2, 5, 2, 4. And we're going to divide this by our negative 35, which we found as the denominator. So again, we want to repeat our first two columns. And we are going to end up with negative 7 times negative 3 times 4, plus 2 times 2 times 1, plus 5 times 10 times negative 2. For the diagonals going up, we're going to have minus 1 times negative 3 times 5, minus negative 2 times 2 times negative 7, minus 4 times 10 times 2. Again, this is all divided by our negative 35 that we found before. When we come over here and simplify this entire thing, we get negative 105 over negative 35, which simplifies to be 3. Now, I want you to pause the video at this point and find y and z following the same format. So, for y, again, if you're looking at the original matrix, you should have replaced the second column with the negative 7, 10, and 1, which would have given you a determinant of negative 70. Denominator is still negative 35. When you divide those, you end up with 2. And for z, again, you're going to replace the final column, the third column, with that negative 7, 10, 1, which gives you a numerator of 140 and a denominator of negative 35. And when you divide those two, you end up with negative 4. So our solution to this equation is either x equals 3, y equals 2, z equals negative 4, or you can write it as the ordered pair 3, 2, negative 4. Either one of those is acceptable. The last thing we want to talk about is how we can use these systems of equations to solve applications. So this first example here is what is known as a mixture problem. A man has available 2 mixtures of solder. One mixture is 25% tin and the other 65% tin. How much of each must he use to make a 56 kilogram mixture with 40% tin? So anytime you're dealing with a mixture problem, it's usually easy is to set things up as a total equation and a percent equation. So if you look at the total equation, let's identify our 25% tin as our variable x and our 65% tin as y. And we know that when we're done, we want a total of 56. So we're going to add so much of x, so much of y, and the total has to be 56. Now, the percentage in this case is going to be the percent of each of these, which is tin. This is going to be our tin equation. So we have 25% of x is tin plus 65% of y is 10, and notice I'm using the decimal, not the full number, because the percentage means decimal, and that this is equal to 40% of our final, which is 56. So that's why it's nice to set up the first equation, the total equation, because then all you have to do is multiply each respective part by its respective percentage. If we simplify, we end up with x plus y equals 56, and 0.25x plus 0.65y is equal to 22.4. So now we have our system of equations. Again, I want you to pause the video at this point and use Cramer's rule to solve this system of equations. So in this case, we only need to really find one of the variables because we can just subtract in that first equation to find the other amount. So if you set up the equation for x, again, you're replacing the first column with the 56 and the 22.4. You should have ended up with 14 for the determinant of the numerator, and 0.4 is the determinant in the denominator. And when you divide these two, you end up with 35 kilograms of the 25% tin. And again, like I said, since we know we have a 56 kilogram mixture total, we can just subtract to get that we would have 21 kilograms of the 65% tin. Or you could go through and set up the determinant for the other variable y, same way we've done before. Denominator we already know is going to be 0.4, and you should end up with that numerator giving you 8.4 over 0.4, which would be your 21 that we have up here above. Let's try one more example here, and this one is a 3x3 system, and it relates the sides of a triangle. It says the perimeter of a triangle is 21 centimeters. The longest side is 2 centimeters longer than the shortest side. These two sides together are twice the size of the remaining side. Find the lengths of the two sides of the triangle. Again, we want to make sure that we identify what our unknowns are. So in this case, we'll call x the shortest side, y the middle length, and z the longest side. You can use A, B, and C if you prefer. We'll use x, y, and z in this case. In this case, we're just essentially looking at each one of these sentences as a different equation. The perimeter of a triangle is 21 centimeters. Take a second and think about what that means. The perimeter means that we add all three of these sides together, and that sum has to be 21. Now, the second sentence says that the longest side, which was z, is 2 centimeters longer than the shorter side. So in this case, that says that z is equal to the shortest side, x, plus 2. And finally, this last one, these two sides together, meaning the shortest and the longest, are twice the size of the remaining side. So x plus z is equal to 2 times y. Now, if you notice here, these are not in standard form. We need to rearrange these so that they fit into the standard form and we can use our formula. So the first equation is okay. X plus y plus z is equal to 21. Second equation, we need to subtract that x over, so we end up with a negative x plus z is equal to 2. And notice here how I'm leaving a space for the y because we don't have a y term in this one. And then if we move that 2y over in the third equation, we have x minus 2y plus z is equal to 0. And so now this is our system of equations that we can go about solving. So if we want to find x first, again, we would set this up. Our denominator is the easy one. Again, we go coefficients on x are 1, negative 1, 1. Coefficients on y are 1, 0, negative 2. And coefficients on z are 1, 1, 1. So we're going to replace this first column with our 21, 2, 0. And we're going to leave the rest of them as is. And again, we're going to go through and find our determinants. So we can do this the long way by repeating the first two columns, or we can go to the calculator. So take a second here, pause the video, and find these two determinants. So you should have found that the numerator was 36 and the denominator was 6, which gives us 6 as our shortest side. We can relatively easy figure out what the other two would be, but let's again just practice Cramer's rule. So if we set up for y, we already know our denominator is 6. This time we're replacing the middle column, so this is 1, negative 1, 1. We'll replace the middle column with our 21, 2, 0. And finally we have our column 1, 1, 1. This will result in a determinant of 42 over 6, which gives us 7. And again, at this point we could easily find that the longest side is going to be 8, because 6 plus 7 plus 8 would be our 21 that we need. Likewise, we have negative x, which is 6, plus z is 2, so we know that's going to need to be 8. But I want you to set up the determinant for the numerator for z just to make sure that you're comfortable with this, then resume the video to check your work. So you should have had the determinant listed there for your numerator of z, which comes out to be 48 over 6, and that gives you 8. So again, in this case, 6 is, if we go back to our units to make sure we have those, centimeters in all of these. Centimeters is our shortest side. 7 centimeters is the middle length. And 8 centimeters is the longest side. So this concludes the video for 6.6 and the final video for Chapter 6. Please go online and complete your homework for 6.6 and then complete your quiz for Chapter 6.